Okay, so we're going to look at AC circuit power analysis, and the example that we have is asking us to determine the instantaneous power as well as the average power. Okay, so what will happen is that using this example, we'll try to really understand what it means when you're talking about instantaneous power as well as the average power. So one thing that we have to understand is that when you're talking about power in terms of circuit, of course, we're just talking about either power that is being supplied at a particular point in a circuit or power that is being consumed at a particular point in a circuit. Okay, so here, when talking about a circuit in general, the power that is consumed by the load, we're able to determine it. We're able to determine the value of that power from either an inductor, a capacitor, or a resistor. Okay, so now how then, what then do we mean in this case? The question is asking us to determine the instantaneous power as well as the average power. How then do we come up with this? What understanding are we able to get from this? Okay, so when it comes to instantaneous power, we are just talking about the power at any instant of time measured in what? It's measured in watts. Okay, instantaneous power is measured in watts, and the same applies to average power. Is also measured in watts. But what's really the difference? What's really the relationship between instantaneous power as well as the average power? Okay, that is either supplied or consumed at a particular point in a circuit. Okay, what do we mean? What is really the difference between these two? So of course, you can look at it from the definition point of view, where we know to say at the power that you have at any instant of time in a circuit is called instantaneous power. Then the average power is just simply the average of the instantaneous power that you have. Okay, that is what your average power is. Then how do we then determine what our instantaneous power is from the information that we are given? So one thing that we will have to note is that looking at the voltage that we have been given and the current that we have been given, this is not written in terms of V, like the capital letter V, like that. This is more like something like that, or even the current is not written as that, it's something like that. Okay, so these two, they are more like fixed, so that like the supply, the voltage as well as the current, they are fixed. Then this one, those two, they are sinusoidal function of time. Okay, their amplitude changes with time, and we're able to observe that from the sine graph. Okay, that's what we actually mean when talking about sinusoidal function of time. Okay, so these two, they vary with what? They vary with time. Okay, while these are what? While those are fixed. Okay, so so what it is that when you are trying to come up with when you're trying to calculate your instantaneous power, the formula that we use is simply power at a particular point. Okay, so you just say pt is equals to 1 over 2 vm, which is the vmax, by im. It doesn't really matter whether I say im or vm, is still okay. Then we say open bracket, we are going to have cosine of the phase angle of voltage minus the phase angle of current here. So even at this point as well, it doesn't really matter whether you say the phase angle of current minus the phase angle of voltage. So in like this part here, this phase angle is related to what? To the voltage. That phase angle is related to what? To the current there. Okay, so it doesn't really matter whether you say whether you get a negative here, because when you say cosine of a positive angle, cosine of a negative is still going to give you a positive. So it doesn't really matter which one you start with. Okay, then here you're going to say plus um, cosine of open bracket, you're going to have 2 omega t there. Okay, plus the phase angle of the voltage plus the phase angle of what? The current there, like that. Okay, so now when talking about this part of the power, it is dependent on two parts. First of all, it's dependent on on the phase angle of the voltage, as well as as well as the current, meaning it's independent of time, as well as this part that is dependent on time, which is dependent on the what is dependent on the frequency. Okay, what you have here is your omega. Okay, and that omega, like how you determine that omega is that your omega is equals to 2 pi what 2 pi frequency. That's why we're saying is dependent on what on the frequency, because I would love to see this as a constant, meaning the only thing that changes is what is my frequency there. So if I change the frequency, it gives me a different value of the omega, which will hence affect what I have at this point. Then this part is one that is independent of time, is dependent on the phase angle of both voltage and what both voltage and current. Okay, so just maybe a quick one in case maybe someone is interested in seeing how this formula is coming about, is the fact that your VT, your voltage, okay, um, your voltage there, which is the maximum voltage of the sinusoid of like so this is like the maximum voltage of the sinusoidal function, voltage function, which will be given as V max. Okay, V max cos omega t there. Okay, plus the phase angle of the voltage itself. Then what about the current? Okay, this will be indicated as I max cos omega t here plus the phase angle of the current. Okay, so now uh, how do we then move from this to that? Because from what we have here we come to this. We know that power, okay, power is simply calculated by voltage by what voltage by current. You might also find that power is determined by, is say, current squared by what by R. How does this come about? It's very simple. We know that voltage is simply equals to what voltage is current by what current by resistance, and we still have this current here, and we are going to say is what by that current. Hence you're going to have what your current squared by what by R. There are times, and we're going to see this in another example that we're going to go through aside from this one, where we will not need to have, like, we don't need to have some voltage for us to determine the power. We can use the current that we're going to have and multiply by that resistor. Like, let's say you're trying to determine the power that is supplied or consumed by that element, which is the resistor. We are going to see that in the next example. Of course, you can also determine the voltage. It will still give you one and the same thing. Okay, so now the thing is that here we'll simply be multiplying. Let me say this is equals to current squared resistor there. So we'll be multiplying this part by that. Okay, that's what we'll be doing. So what it means now is that we are going to say our power, let's say PT, will be equals to our V max. Okay, our V max cos that plus phase angle there, okay, multiplied by what our I max cos omega t plus the phase angle of current. That's what we have. Then I can write this as my PT is equals to, I can say Vm, okay, V max I max there. Then I can say I have cos omega t plus the phase angle of the voltage multiplied by cos omega t plus the phase angle of the current, like that. Okay, that's what we have. Then how are we able to move from what we have there to, how are we moving from what we have now to what we have here? So we are simply using product formulas. One of the product formulas, which is simply cos A cos B. What it simply means here is that this part here is representing one angle, and this part is representing what another angle. I have cos and I have cos here. Okay, so for example, what we are saying is that this is cos A and this is cos what, that part is cos B, and you're going to use the product formula for cos A cos B to try to come up with it's more like you're just trying to simplify that part. Okay, so the product formula for cos A cos B is simply like, it's written as cos A cos B. It's more like this when you're dealing with it's like it's the same, you have cos but what you have here, the angle is different. It's more like you have like 4x here, then maybe here you have 3x. Okay, so you want to try to simplify that one. So this is simply equals to 1 over 2, okay, open bracket, you're going to have your cos a plus b, okay, then you're going to say plus your cos a minus what, a minus b. And we talked a lot about this one when we were doing a lot of some integration in math. Okay, that's what you're going to utilize. So remember to say we had a 1 over 2, so it basically means you're going to say your pt will be equals to, you have your 1 over 2, okay, 1 over 2, then you're going to have your v max, then your I max. Okay, so what it is that this part is your A, that is your B. So you're going to say your cos, remember to say we said A plus B, so this is simply our A is omega t, okay, omega t plus phase angle of the voltage plus we're going to say plus B, and our B is omega t plus the phase angle of what, of the current we close, then we say plus that would be cos, okay, cos this part now, your A minus what, minus your B. You observe to say this one minus that one, that would be a 0. So you're going to have your phase angle of the voltage minus your phase angle of the what, of the current, like that. So now what you observe is that what I have here, if you simplify it, this plus this is going to give you these two that we have there, and we have this and that, okay, we also have this and that. So it's just like we're just swapping, this one is here, then this one is where it's there. So that's how we come up with that one. Okay, then from this, how are we then able to, we have said the average power. This is for instantaneous power. The average power is simply just the, like the average of the instantaneous powers, and you can just simply indicate it using, you say pt will be equals to in fact, let me say p average, sorry. So p average is going to be equals to 1 over 2 I max, then v max, or v max I max is simply one and the same thing, cos that would be cos phase angle of the voltage minus the phase angle of the what, of the current there. That's how you're going to be, that's what you're going to be using to determine the average power there. Okay, so we really need to keep these formulas dear to us. Of course, it may not really be necessary for you to know how to come up with them, but just in case you might need it at some point, okay, this is simply how we come up with those two formulas. Okay, so now before I dive into answering this question, I would love to bring to your attention is that here you have your cos and here you have a sine. So we need to be familiar with how how we transform those identities. Like we simply call it sinusoid transformation. Okay, so here are the tools that we use when transforming. So what it is that if I have minus, okay, minus sine omega t, and there's a time again when I have minus cos omega t, okay, then there's a time when I can have plus or minus cos omega t, and there's a time when I can have minus positive sine omega t. This will be equals to, want to know how we can, because I have a cos here and I have a sine, I can't really pick direct the way it is and utilize it. No, I have to, it's either I put this in terms of sine or I put this in terms of cos, so that we have cos here and we have cos there, hence everything will be balanced. So for the first one, this is simply equals to sine what, sine omega t here plus what, plus or minus 180 degrees. Okay, what about the second part? This is going to be equals to cos omega t plus or minus 180 degrees. The third part, this will be equals to sine, okay, omega t plus or minus 90 degrees. Okay, then the last part you have cos omega t, you're going to have plus or minus 90 degrees. So what you observe is that what I have here is simply this one. I don't want to put this in terms of sine, I want to put this in terms of cos. Okay, so what does it mean is that what you have is a negative here, which is what you have here. So what you're going to have is that you're going to write your 33. Of course, you're going to have your 33, but you're going to write cos. No need of putting a negative, as you have observed there. It doesn't really matter what I have here, whether it's positive or negative. I don't need to indicate that negative there. So I can say I have 33 cos, okay, open bracket, my omega in this case is 50 t. Then I have minus 30 degrees. Then the thing is that I had a minus here, okay. Then what do I have inside here is a plus 90 degrees, okay. So what it means is that it doesn't mean you need to make this a 90 degrees. No, you need to bring in the 90 here. I'll say plus what? Plus 90 degrees right there. So this would be like 33 cos 50t. That would be plus 60 degrees there. Okay, that's what we have. So instead of using that, we're going to say this is equals to minus, oh wait, not a minus, but plus sign, plus 33 cos 50t plus 60 degrees, and that's what we're going to utilize. Okay, so it's very important that we really keep in mind how to transform these. They really come in handy when you're doing a lot of such questions. Okay, so now let's try to come up with the instantaneous power as well as the average power. Okay, so we said that our instantaneous power PT was equals to 1 over V max. In this case, my V max, you're talking about your 160 multiplied by I max, which is your 30. Okay, I mean your 33 rather. Then you're going to say we're going to multiply this by we say cos. Then I'll say here the first angle for the voltage is simply a 0 minus the first angle for the current is 60 degrees. Then I'll say plus. Then here I have my cos. Here we had 2 omega t. What does this mean now? My omega is 50 by 2. That gives me a 100 t. Okay. Then here I'm going to say plus 0, which is the phase angle for the voltage, plus the 60, which is the phase angle for the current, and I'll just say 60 degrees there, like that. Okay, so now we're going to say P, the instantaneous power will be equals to we have the 160 multiplied by 33. It gives me 5280. I divide by 2, I get 2640. Okay, then here I'm going to get when you say cos 60 or cos minus 60 is still one and the same thing. It will give us 0.5 or 1 over 2 plus I'll say cos 100t here, okay, plus 60 degrees, like that. Okay, so this value we can distribute that into what we have, so that would be like 0.5 multiplied by 2640. What I end up with is a 1320. Okay, then plus that by that, you get 2640 cos you have your 100t here plus your 60 degrees. So of course I'll do that, and we know that this is measured in what? That is measured in watts, and that's our instantaneous power. Okay, now let's try to come up with the average power. Okay, so for the average power, I will say power average, this is going to be equals to 1 over 2 our V max, which is 160, our I max, which is 33. Then we have multiplied by cos the phase angle for the voltage minus the phase angle for the current, which we found as negative 60. Okay, so what do we have now? We said 160 by 33 divide by 2, it gives us 2640. In this part we're going to get 0.5, which is 1 over 2. So I multiply by 0.5. What I simply get is 1320, okay, watts. That's what we get as our average power. Okay, so this is just, this question appears very straightforward, and it is very straightforward, very straightforward. In fact, what I just wanted to do was that I wanted to utilize this question to try to explain how we come up with instantaneous power as well as average power, how those formulas come about, because we're going to be utilizing them a lot, and it's very important that we really understand where they come from. If we understand where they come from, it becomes much simple and fun, I guess, to solve a lot of questions. So thank you very much for watching. Make sure to say you watch out for the next video. In case you have not subscribed to the channel, please subscribe so that you don't miss out on any content that we're going to be uploading. We have a lot of content that is coming up, both in mathematics as well as anything else that is engineering related, as I like saying. Thank you very much for watching once again.